Testing sound. Always good to make sure that that works. Well, welcome to my stream. I'm still doing a little bit of setup work. Let's see here. Let's see. Ba, 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 ba. Yay. All right then. So, what was the last thing? Let's look and see if we've made any changes since last time. Yes, we've implemented the parsing of function calls. Uh, you know, now I'm kind of wondering, once we have the parsing of function calls, whether we should make some tests for this before we start implementing actual function calls. Uh, Also, too, does this compile? Oh, that's right. I was trying to get something to compile that wasn't. That's right. That's where we left off. Um, why this doesn't work. So func name does happen to be an identifier. What happens if we do this? Func name is a reference. Where else does it appear? Oh, this is an identifier token. You know, or is it? No, I do try to parse it as an identifier. Okay. So func ID. So then we look, does func ID hold the identifier, the parser identifier? Uh, if it does, we assert that it does. So basically, if we got a valid result from parse identifier, it must be an identifier. Okay, that's right. Um, uh, now, let's see. Oh my. All right. Fixing the clang tidy error. It thinks it's an identifier reference. So now when we call func call, and why does it not like this? So well, first, okay, we need this here. Ah, okay, that works. That's as annoying. There are a whole bunch of error messages all around the idea that grr. And this is a double move, sadly. I wish there was sort of a variant of make unique that was make unique variant um, that allows you to call the variant with perfect forwarding, the variant constructor with perfect forwarding, so you didn't have to, I don't know. Yeah, I don't know. Anyway, this works. We have. Um, there's a double move, but it's not that big of a deal. Okay, now we can commit. There we go. All right, function call parsing accomplished. Now that we have that, let's make actual function calls work. Function calls are going to be weird um, from a working standpoint, like how to make them work. Um, Now, from a printing standpoint, I think I have them covered. So let's go and double check here. So this is to-do'd as well as the declaration. They're both to-do'd. That's okay. Same for infix, but prefix got prefix down. um, and func is the identifier, so basically print out an identifier, which printing out an identifier is paramount, just printing out the name of the identifier. Um, then we print out go through all the parameters, and for each parameter, put in a space, and then the argument, close it off. And the argument might be an expression, so we visit it. Okay, yep, this is exactly right. All right, so we do not have infix or evaluate for function calls. So let's do, first of all, declaration. This one is going to be tricky. How to implement a function declaration. So first thing we have to do is we have to get the value of the identifier. So first we do in fact, I don't even have to say this. I can just do find identifier. fdecal.name, and it takes up only 54 columns, so that's good. I actually think that I need to get an extension for OBS called Item to be set up, because I think I could get streaming to work a lot better to the 3 platforms if I didn't go through restream.io, which is what I'm doing right now, and instead went just directly to using Item allows you to stream directly to several different places at once. And I think it handles the different stream formats that the places have correctly, more correctly than Restream does. And I know that I have the outgoing bandwidth to handle multiple 4K streams, and I have a computer that's beefy enough to do the compression for multiple 4K streams. So, especially if I'm not playing a game at the same time. Hello there, Nulkuro. Welcome to the stream. I'm streaming to several different platforms. Anyway, trying to implement the function simple evaluator. This is basically a tiny programming language that I've been working on. I have the grammar sitting here in parser.hpp. I have the grammar sitting up here. Currently, I'm implementing function declaration and function calls, um, which has been kind of tricky because of the way stack frames are being handled and stuff like that. Also, too, the implementation of function calls has introduced types into the language, which the language kind of had before, but the type of everything was unsigned 64-bit integer. That was everything's type. And now I have the function uh, type. And so that is going to be interesting. Now, stack index. Oh, yes. So C. Oh, no, no. This is a declaration, right? Okay. So this is an equal sign. Oh my. And function declaration is, how did I handle that now within my variables? I have variables, not see here. Need to look down here where I define them. It's been a while since I've looked at this code. Oh, well. No Kuro left. That's very sad. Hmm. So current result, no. What do we want this? So stack, and then in here we have var val t, and so we need a new var val t. And here, uh, there. Oh my. There. That's good. Yep. So all these asserts. The parser should only be allowing function calls or function declarations to be occurring at the top level, the at the global level. Um, there are a few different reasons for this. Well, in fact, there's actually only one primary reason. The primary reason is that we're not implementing what are called closures. Closures are functions that contain a reference to the stack frame in which the function was declared in. In Python, this looks like, let's do Python file. Right. So in Python, if you have like a function like this, and it has a parameter, and then you have right, you can return the B function. And when you return the B function, so we have code here that calls right, and then if you print B, when you do this, and no, print is, yeah, print is a function call in Python nowadays. So I don't know why it's saying unresolved reference to print, because it's a built-in. Oh, sure, we'll configure a Python interpreter and we'll say system Python. There. Okay. All right then. Um, so if we did this, what we'd get out when we ran it, in fact, I can go run it here. If we do it, run it here, Python 3 scratch.py, right? Prints out 1. And if I changed it to be like 5, it'd print out 5. But suppose I did this. Right? Suppose I did that. I get 510, 510. And in fact, so what's happening is this param is binding to the value of a function when it's called. So B function sort of remembers what the value of the param was to a function when this def is hit. And that's called a closure. Closures are really tricky to implement in languages that have a stack that's in fact actually a stack. In order to implement closures properly, the function that the closure here has to sort of store the stack frame in which the function declaration was seen. So that when an identifier is referred to from inside of it, it can look at the stack frame in which, and this is the runtime stack frame in which the function was seen, where the function declaration was encountered, and then grab the param from that invocation of the function and not some later invocation of the function. In order to keep this B1 and B2 as being distinct things, the B1 has to contain sort of a reference to the stack at the state of the stack at the time of the invocation of a function. And B2 has to contain a reference to the state of the stack at the time of its invocation of the a function, right? And I don't want to implement closures. Now, C++ has lambda functions, which can occur as nested functions, but lambda functions very explicitly have to sort of make a copy of certain variables at the time that the lambda function is created, or they have to take references to certain variables at the time the Lambda function is created. And if they take references to those variables, then the Lambda function becomes invalid as soon as the scope in which it was created exits, because those references are now referencing values that no longer exist. The stack frame in which they are on is gone. Because in C, there's no way, in C++, there's no way to keep a stack frame around after the function exits. So the C++ implements lambdas, which kind of, sort of have a poor man's closure, but it's a closure where you're explicitly copying part of the stack state into the lambda at the time you're creating the lambda instance. And so it's not a true closure in that it doesn't hold the state of the entire stack. It holds only those things that you said should be copied into the lambda. And it's also not a true closure in that if you don't copy the value in, and instead you put a reference to the value in, well, when the stack frame goes away, it goes away. Whereas a normal closure, the stack frame sticks around for the entire lifetime of the closure. And I want to implement a strict stack, and so I'm not going to have closures. And if I'm not going to have closures, I can't, if I allow nested functions like this, well, those functions are going to be like they reference a variable. That variable is going to have to be a global variable. It can't be a reference to the scoped variable, and that breaks all the scoping rules. And so it will just look weird. It won't work right. It will be like this function was declared at the global scope anyway. So what I have in this thing is I have something which basically says all functions must be declared at the global scope, at the lowest, at the 0th level stack frame. And that's that. And that's why I have that assert in there. That assert also exists, or that rule also exists inside the parser. The parser, at the time the function declaration is being parsed, will check that that function declaration is being parsed in the global scope and act accordingly. Like if it isn't being parsed in the global scope, it will error out and go, you can't have a function declaration here. So yes, that is what this assert is about. These other asserts are just about, oh, let's make sure that the stack frame being referenced is one that exists. And I want to keep this assert looking this way because just a bit. Somebody sent me a question, and actually just a bit, I'm going to switch to chatting mode temporarily so I can kill the source of toast. So chatting. And also kill the source of toast because I don't want toast popping up on the screen during my chat. And kill other sources of toast as well. Any other sources of toast? No, no other toast. Good. Okay. What's toast? Toast are those little messages that pop up on the bottom of your screen, like a piece of toast popping out of a toaster. That's toast, for anybody who is wondering. Okay. So all these are just checks to make sure that all the values are saying that, okay, it's pointing at a stack frame that actually exists and that the it's pointing at a variable, an index into the variable table that actually, is an existing variable, that kind of thing. So that's what this is about. Ideally, I would check to make sure that the variable doesn't have a value, which means I should have some kind of default. Uh, um, Here, I should have some kind of variant thingy that is a nothing. But yeah, I don't. And I don't know what to do. That's a thing to do a bit of research on. How do I have a variant variable that's a nothing? Because that's another thing I should check here. That at the time of this assignment, at the time I'm setting this value, the value that's there should be nothing. It should be not contain, never have been assigned previously. Um, because once, like if you declare a function, uh, you can't then go, if I declared a function called find identifier, I couldn't then say find identifier equals something else, right? Values, whatever, the function's there and you can't reassign it. Also, too, if I previously declared find identifier as a variable, I shouldn't be able to declare it later as a function. And because I don't have functions as values right now. All right, then. Stack. Stack ID info. Okay, this is actually assigning the value, and I'm storing a bear pointer here, which is not the best practiced, but it's what I'm doing. I don't know what to do about that. This basically says you can't destroy the parse tree until until the execution is finished, which that isn't what the parse tree isn't destroyed until the execution is finished. But this says it can't be because there's a pointer that's non-owning that's pointing into the middle of the parse tree someplace. Um, so now let's see. Let's look at this function call. This is going to be a lot trickier. Um, so first of all, let's build this and make sure that this actually builds. Okay. Actually, let's make sure all the tests run it so that I didn't break any of the tests. Yep. Okay. Um, Committing it every step of the way so that I can roll back really easily. Yeah, because this one I think is going to be complicated and I want to be able to roll back. Um, all right. Now, stupid thing. Focus follows mouse. Return do something rather than nothing. Okay, so what does this need to do? Yes, first, yep. Absolutely not. not std has value. Um, we don't want get. What do we want? We want time to look at variant again. There we go. Vector. Bad variant access. In place. Holds alternative. That's the right one. Stupid thing. Yes. And no, we don't want varref.pointer. We want varref, right? Because it's a variant. No, not dot pointer. It's not a pointer, right? Yeah, exactly, like that. Okay. Why do you keep on insisting on having varref.pointer, right? No. Um, okay. Now we have our function declaration. Um, yeah. No static casting here because that's not. Why do you keep on trying to do dot pointer? What is it with you, you stupid AI? Okay. Up. My batteries are about to go out just a bit. Let me fix that. Also, let me double check that certain thing didn't happen and I don't have any sound anymore. I do. Good. All right. Time to switch the batteries. Luckily, these headphones make it very quick. Audible again. Sadly, I'm going to have to go fishing for my battery because I dropped it. You can still hear me, but cannot see me while I'm fishing for my battery. And put it in the charger because these are a very nice pair of headphones and they have a little charger so that and a spare battery that came with them so that there's always a battery to swap out with. And not see. All right. So now that we've found our function declaration, we can do yeah, this is except there is a problem now, which is indeed. Um, yep, that would be the right thing to do. Set current result back to 0. So we go through all of these. Then what we have to do is we have to create a new scope. Did I add that as a separate function? I don't think I added a separate function to create a new scope. Right now, a new scope is created when I run a statement list. Um, oh, this is going to be really, really ugly. uh, no, it's not coffee. So why is this going to be ugly? So the next thing that I'm going to be doing is I'm going to be evaluating this statement list. And the statement list is going to create the a new scope that will have a bunch of variable declarations in it. But we want to fill up the first certain number of variable declarations with our new argument values. So I think what I'm going to have to do here, oh, this is so ugly, but I don't think there's any way around it. Um, that is what we are going to have to do. And it's actually going to be var val, not var info. And then here, uh, assert that it's empty. And then how does this part work again? Oh, yes. And that's not how this goes. No, no. We're going to be visiting. Uh, yes, that's what we're going to be visiting. And yes, we're going to have lots of assert here. There we go. I'm tempted to assert that the body is a statement list, but I'm not going to do that right now. It, to some extent, doesn't matter if it is. So here in statement list, no. Uh, there we go. Okay. So are we storing our variable values? So right now we have a stack frame, and in that stack frame, we initialize everything to varval t0, which may or may not be, well, currently it is going to be correct for all except for the very top level one. So, oh, this is, yeah. I don't like this, but this is what I'm going to have to do. Yes. There we go. No, funkargs.clear. We don't do that here. We do that later. Actually, we do that here. That is the right place to do it. And down here, what I'm going to do here is I'm going to assert that it was consumed. We're going to assert that the function arguments were consumed. Okay. So our visitor pattern, right? The visitor pattern, we have a single argument. We kind of need to pass another argument optionally into it. But the visitor pattern, we can't really do that. So what we're going to do instead with the visitor pattern here is we're going to use the visitor itself to sort of pass the argument anyway. So we're just going to have this vector here that we always have in visitor. And whenever we encounter a function call, we're going to initialize that vector to point at to it contain the values of the evaluated function arguments. And then once we hit the statement list, that, you know, the block of statements that contains the function. Oh, so annoying. So annoying. I don't know if I insist that functions contain statement lists. Let's double check in the, if I did that in the thing, if it must be a statement list. Yep, sequence. Yep, it must be a statement list. Okay, that's good. Did not allow for function body to be a single expression, because if I did, oh my, that would be a pain. That would be a pain. but I didn't. So it's always going to be a statement list. It's better always be a statement list. And so then it's going to evaluate the body of the function after setting up this arguments. When it evaluates the body of the function with the visit of the body down here, um, down here where I'm visiting, this is visiting the body. So then that's going to jump up to here to evaluate this statement list. The statement list first had a bunch of code that already existed that initialized the stack frame for that statement list, because every statement list is its own scope. And so it initializes a little stack frame for that statement list, and that stack frame contains variable slots for all the variables that are in that scope. And for a function, this is specially set up so that all the statements, all the variables that are part of the function body are also given variable slots inside the statement list that the function can, is part of the function, the sequence here that's part of the function. And so those variable slots um, are created here in addition to any variable slots that are needed for variables that are declared inside this sequence. And so then this checks, okay, first this assert is about if we must either have no function arguments or the statement list variable declaration, the number of slots that it has must be at least the number of slots needed for all the function arguments. Okay. Then if we actually have some function arguments, then we store a reference to, why does this not work? Oh, okay. There. Now we're not getting now we're not getting yeah. And it shouldn't be const actually. Yeah, that's perfectly valid. Why does it not like that? Well, hmm, okay. We're going to have a different way of getting at the type that's just as flexible. Um, what happens if I change this though? There we go. Now it's correct. How ugly. What do I need to include this? I need type traits. Have I included type traits? No. That's annoying. Okay, so then we go for the we go through our function argument list. If we have some function arguments, then we sort of keep a temporary kind of a reference here just to make the rest of the code nicer to look at of our our value, our slots, our list of value variable slots. And then using var list t, so basically we're naming the type here, and then here the type of whatever this happens to be, which will be a vector varval. But I didn't want to mention it because I want to set it up so if I actually change this type, I have to change as little code as possible. That thing will still continue to work. I could have done decal type func args because these two should be the same, but I don't want to count on them being the same. And so I'm going to do it this way instead. And this happens to be a reference type, so I have to do remove reference in order to get the actual type that I want. So var list colon size type. So whatever the proper size type is for this arg index. So we're going to start, we need this because we need to know where in top vars to be stuffing our things. Is there a better way I could have done this? Could I have done a copy and then just, I think I could have just done a copy. What happens if I do this? And then here, like this. Poof. Because we've already done the asserts to make sure that there's actually enough space in top vars for this to work. All right, this does exactly what I want. All right. Okay. So then I basically copy in the function arguments into our variables, into the very first slots of our variables. And then we do funcargs.clear to basically consume the function arguments. And then we do whatever it is that we were going to do. We've initialized the first set of arguments to the function arguments, whatever they were. And then down here, we assert that the function arguments were indeed consumed. Because things get all messy. Like if I don't consume them and then there's some other statement list, this is what needs to consume them. Because one of the things that might happen in the evaluation of all of these statements is that might be like a while statement or something, and it will have its own statement list, right? And then that own statement list will see the func args, and I will see that, oh, there's some arguments there, when in fact there aren't any arguments there. It isn't a function call even, right? It's the body of a while loop. So I have to clear it as soon as I consume it. As soon as I copy them in, I have to clear it. So then here, as I'm evaluating the body, the arguments are no longer seen. The arguments are no longer something that will affect execution um, of the rest of the code. Because again, if I see another statement body, like because here, like you look at the grammar, there are other places where this can occur, right? Um, there's anytime you have a statement, there can be blah, any statement at all. It can instead be a brace separated sequence. So there are a lot of places where you can actually, have this here. The while loop, for example, requires a statement, right? And the statement can be, all kinds of things, but it could be a sequence. And anytime you get the sequence thing here, it then will be a statement list. And here, if this sequence inside the, inside this expression, which could be in a whole lot of different places, sees that there's function arguments, it will try and copy them in. And there might not even be enough variable slots there inside that one. There might be 0 variable slots. There often will be. And then, of course, there'll be no place to put the arguments, and then assert will fire. This assert will fire. And so I have to clear out the arguments as soon as I copy them in to signal, as this part is being evaluated, that there are no other function arguments, that that there aren't any function arguments, that there wasn't an enclosing function call, or there wasn't the statement list that's being executed is not the body of a function. Now, what I could have done instead is have a separate production for function body, and had function body be this plus sequence plus this, and then have a simple evaluator for function body that did something special, except it would have still had a sequence in it. I don't think that would have worked. I don't know. But, and this is kind of ugly, but it's necessary. The way it works is necessary. And we'll compile, and it will run. And I don't have time right now. The next thing is going to be actually testing function execution to make sure that function execution works. So there we go. And because of this, I don't need type traits anymore. I can actually remove this. So that's good. I always like being able to remove things that are, why does this have the debug on it? Huh. I don't know. I don't know why that symbol is there. Maybe I can actually evaluate this. Oh, anything that's a const expr, I can actually evaluate right then and there and just see what it does. Oh, that's kind of amusing. And then it will tell me what the result is. Ha, how amusing. All right, that's kind of fun. So we're done for this evening. Testing of all of this stuff is going to have to come next time I stream. Have a good evening. Sorry you came in towards the end of the stream, Guardfather, and listened to me rant about my poor well, not my poor implementation, my kind of ugly implementation of this that I'm not overly happy with, because there's a certain amount of asymmetry in things. And basically, I'm doing argument passing in a bizarre way. Not just function argument passing between different levels of the visitor here in a weird way. And so I don't like it. But that's what I was ranting about. Anyway, I hope you come back. I hope to be streaming again, maybe Tuesday evening-ish. Yes, Tuesday evening-ish. That's when I hope to be streaming again. And yeah, good night, everybody.